and welcome to our next lesson about functions. We're in our functions unit. Today we're talking about maxima and minima of functions, and we're talking about what it means for a function to be increasing, decreasing, or constant. Okay, so our objectives, what you should be able to do, what you should know by the end of this lesson, are how to identify minimum and maximum values of a graph, and how to identify intervals on which a function increases and decreases. And like always, make sure you're taking notes. Make sure that you guys write down any questions so we can get that sorted out and we can get you the help you need tomorrow in class. Alright, so first of all, maximum and minimum are exactly what they sound. It's the highest value of the graph or it's the lowest value of the graph. It's the max of the graph or the min of the graph. Okay, so a local maximum is locally the largest value of the graph. It's the highest y value in a certain area of the function. Local minimum is the lowest y value in a certain area of the function. Okay? Note, they don't necessarily have to be the highest or lowest point on the entire graph. Okay, just in that certain area. That's why it's called local. We're only looking at a certain area. Okay, so for example, if we're looking at this function down here, this graph, this yellow point on the left here, it's not the highest point on the entire graph, but it is a local maximum because it is the highest value in that area, in a certain interval of the graph. All the points around it are smaller than it, so there is a local max at, and we want to name the y value there, so there's a local max at 1, 2, like 2.7. Something like that. Over here, there's a local max of, what is that, 1, 2, 3, like 3.7? I don't know, something like that, okay? And then this local min value, this blue point down here, let me bring the graph up so you can see a little better. This blue point down here is a local min. Again, it's not the smallest point on the graph, but it is a local min because if we look at the stuff directly around it, everything is higher than it. It's the smallest y value in that area of the graph. So there's a local min at 1.6. Okay? So you're identifying the y value that is either the highest or the lowest point in a certain area. Alright, so it's very similar for a global max or a global min. So global means the entire function. So a global maximum is the highest y value on the entire graph. A global minimum is the lowest y value on the entire graph. Okay? A local min or max is not always going to be a global min or max. Alright, so if we're looking at this function here, we have a global maximum at this right point because it is the highest point on this graph. It's the highest point on this function. So there is a global max at like 3.7. Alright, there's still a local max at 2.7, but it's not the global max. There's a local min at 1.6, and our global minimum is negative infinity because this goes down forever. So there's not a set value that is the lowest point on the graph. It's going to go down to negative infinity. Alright, so now let's talk about increasing and decreasing functions. Increasing and decreasing functions are exactly what it sounds like. A function is increasing on an interval of x's when the function goes up on those x's. A function is decreasing on an interval of x's when the function goes down for those x's. And a function is constant, it stays the same on an interval of x's if the function stays the same on those x's. Okay, so let's look at an example of that. Alright, so for this function, we always read a graph from left to right. Okay, it's like read a book. We're going to start on the left, go right. So if we start on the left, what's happening here? Well, it's going down. So we say that the function is decreasing. Okay, so it's decreasing on the interval -2 to 0. So from -2 to 0, if we just look at that part of the graph, it's decreasing. It's going down. Okay? And we don't want to include -2 or 0 there because it's not really going down at -2 and 0. It's kind of changing directions at -2 and 0. Alright, so the function is staying constant. So if we look at the interval 0 to 3, if we're just looking at that interval, the function's staying the same. It's not going up or down. So we say a function is constant from 0 to 3. Okay? And then continue reading the graph from left to right. So we're looking at from 3 to 5, the function is going up. Okay? So we say the function is increasing on the interval 3 to 5. Okay? We're just going to look at a couple of these examples. Okay, so if you guys have a graphing calculator at home, use these to graph some of these. If you don't, that's fine. I'll kind of sketch some of these graphs. For f of x equals 3x minus 8, we know what that graph looks like. It has a y-intercept at -8, has a slope of 3, so we go up 3 to the right 1, up 3 to the right 1. Okay, so there's our graph. Okay, so if we're reading that graph from left to right, from left it starts down here and it's going up. Okay, so we say that that function is increasing. So this function is increasing, and then we're looking at an interval of x values. So where is it starting? So it starts increasing when x is negative infinity, because this continues to go on until x is negative infinity. And it's going to continue increasing. It's going to continue going up until x is infinity, because it is going to go up all the way to the right. Okay? So x is increasing from negative infinity to infinity. It's increasing that entire time. All right, let's look at one more example there of a line. All right, so if we look at the second one's going to be a line. So that's going to be plus 4y. All right, so if we subtract 2x on both sides so that we can get it in slope-intercept form, so then 4y is going to equal negative 2x plus 12. It's one of the worst ones I've ever seen. Alright, so negative 2x plus 12, divide by 4 on both sides, and y is going to be negative 1/2 x plus 3. Okay, so again, we should be able to graph this at this point. So if we're graphing this, it has a y-intercept of positive 3. Alright, so start at 3 on the y-axis, has a slope of negative 1/2, so down 1 to the right 2, or up 1 to the left 2, and there's our line. Okay? So, ask yourself what's happening from left to right. If we start on the left, it's starting up here, and it's going down as we go from left to right. So, that function is decreasing. And because it is always decreasing, it's decreasing from negative infinity to infinity. Okay? Alright, now we're going to do one more, and it's not a linear function. So again, if you guys have a graphing calculator at home, use that graphing calculator. If not, you can go to desmos.com, because we haven't talked a ton about graphing things that aren't lines yet this year. Alright, so you can go to desmos.com and kind of type in some stuff. We're going to look at h of x equals x squared plus 4. Alright, so I'm just going to kind of tell you how that looks. So for h of x is x squared plus 4. So think about when x is 0, what is y going to be? If we substitute 0 for x, y is going to be 4. So when x is 0, y is 4. If we substitute in 1 for x, 1 times 1 is 1 plus 4 is 5. So there's a point at 1, 5. Same thing with negative 1. There's a point at negative 1, 5. There's a point at 2, 8. Okay, and there's a point at negative 2. So this is what our graph looks like. Alright, so think about it again like reading a book. We're going left to right. So if we start on the left, it starts at negative, it starts at negative infinity on the x-axis. Okay, because it starts all the way to the left. There's no point that it starts at. So it's going to start at negative infinity, and we're going down. Okay, so we say it's decreasing We're decreasing from negative infinity. Remember, infinity signs always have parentheses. And it's decreasing until x is 0. So it's decreasing on the interval negative infinity to 0. Alright, and then start at 0. What's happening there? Well, it starts going up. And it's never going to stop going up. It goes up forever. So we are increasing from 0 until infinity, because it's going to continue going up forever. Okay, so this is where it's decreasing and increasing. Alright, if we're identifying, I don't know if you can see that down here. It says also identify any minimum and maximum values. For the lines, there weren't any minimum and maximum values. But here, we do have a global min, a global minimum, meaning that it is the lowest point on the entire graph. And what is the lowest point? Well, it's up 4. So we have a global min at 4. Okay? So right there, those are the two things you should have learned. We can identify decreasing and increasing intervals, and we can identify minimums and maximums. Okay, again, write down questions that you have. We'll get it figured out tomorrow. Have a good night, guys.